to understand the uniqueness of the Salish Sea, that requires some understanding of the physical and biological processes that have resulted in the way that the Salish Sea looks today. And so, starting in just that real fundamental ecological question of what shapes the Salish Sea, which can really be the same principles that we can think of about shaping any ecosystem. And so obviously this class we're going to talk all about the Salish Sea, but the framework and the way that we do that can be applied to really anywhere in the world. And so I think it's interesting to think about it from that perspective as well, that hopefully we'll develop a better understanding and connection to this area, but you could use that same approach if you went anywhere else in the world. So we're back talking about the Salish Sea, and here's our map again that we'll look at quite a bit, but gives you this indication of where we're at. And that is a really interesting landscape, that it's not flat, it's three-dimensional, and there's a lot of variation with where the marine environment and terrestrial environment interact. So what's shaping the Salish Sea from an ecological perspective, just thinking about from the lens of the organisms and the environment and their interaction, what pieces of the puzzle are important to know. And I think you could really break any ecosystem down into 4 distinct components. The geology of the area is important, the geological history, the type of rocks, the geological processes that have shaped the landscape are vital for determining the biology of the area, so what organisms are there. And that can include endemic or native species. That could also include introduced, exotics, or invasive species, all words for things that didn't come from here but are here now, as well as the abiotic environment, so the environment that's not the biology. You can think about weather, climate, things like that. Is it cold year-round? Is it warm year-round? How much rain do we get? What's the temperature? How much sunlight? All the abiotic environment is really important in driving the biology and ecology as well. And people are certainly shape ecosystems. Wherever you're at right now, if you look around, I'm sure there's evidence of people shaping the ecosystem, but that has occurred for a long time. And so we'll look at both modern impacts of people on the ecosystems, but also pre-contact impacts of people in the ecosystem. So to me, any system you can really break down in these 4 components: geology, biology, abiotic, and human or people. And the Salish Sea map, one of the great things about that, it's that line around the watershed. It's really important to have that watershed view, that we're not just talking about the sea, but we're talking about the interaction of terrestrial and marine. And whatever happens in the watershed has an impact in the marine environment. So if you want a healthy marine ecosystem, you really have to start in the watershed. And so starting with that watershed view is really important. And this image here kind of shows that an idealistic, sort of system with minimal human impacts within the ecosystem, a vibrant coral reef and fish ecosystem, and then through deforestation, a lot of that's lost. You've got increased sedimentation that's killing corals, it's reducing fish populations, and that's really changing the way it works. And so these terrestrial impacts are not just terrestrial, they're also manifest in the marine environment as well. So when we go out on our beaches today, this is an image from Birch Bay, I believe. If you go out on our beaches today, we're at that interface, and so what's happening on land makes its way into the marine environment. So that connection's quite important. And this connection's been realized and worked with for thousands of years. This is a diagram from the Matthews and Turner reading, and this is a diagram based on North Hoyt, which is in the Celtic territory north of Vancouver Island. and it's one of these places where there's just a massive resource intensification and modification of the environment. That in this one area you can stand and look around, and you can see berry gardens, you can see root gardens in the estuaries, you can see shell middens, evidence of large winter villages, as well as these intertidal stonefish traps. And so these are big rock walls that were placed out in the low tide line, and fish would swim in as they're coming into to a river to spawn. Tide would go out and it would trap them in these big pools. This is a really great way of harvesting salmon because they're all there in a pool, and you can just pick out the individuals that you want. Let's say you're going to cook the fish fresh, so you just need one or two, or if you're going to smoke it, you want a certain fat content, so you can kind of select for that. So it's a really nice way of doing selective harvest of salmon, as well as clam gardens, which we have a whole lecture devoted to. That's one of my academic areas of research, which are these beaches where large rocks are rolled to a low tide line to terrace the beaches out. So similar to the way that you would terrace a hill to grow more grapes, you can terrace a beach to grow more clams. And so these modifications have been happening for thousands of years. And one of the things that I want to convey is thinking about this timeline and methods of modifying the environment, that people have done that since time immemorial. And that really, if you want to understand the Salish Sea, you have to understand these modifications from mountaintop to seafloor bottom, that these modifications have been happening. And they're obviously different now than they have been traditionally. But if you want to understand the ecosystem, you need to understand these modifications as well. You could imagine going out to a clam garden and seeing this big pile of rocks on the beach and making up some story about a flood or a landslide or something about how all these rocks got here. But if you don't understand the cultures of the landscape, you're not going to be able to understand the features of the landscape as well. We are in a very active geological region. We have a very diverse habitat, and part of that's because of the collision of plates. We're in a subduction zone where the oceanic plate is going below the continental crust, and that's creating a lot of our mountains and a lot of that uplift. And so you can think about globally here, it's showing the North America, the continental plate moving west and the oceanic plate moving east, and we're at that collision zone. More recently, or recently, we've had a very large ice age that had a massive impact on the Salish Sea. This map kind of takes a minute to get your eyes adjusted to it because it's a bit different than the way we're used to looking at this area, but you can see basically a Google map here showing I-5 running north and south, and all of this white is ice, and all of this land is now underwater. So the sea was much lower. There's all this water that's held up on land in the form of ice, and this ice is covering all of a good chunk of western Washington all the way down through Olympia and Tacoma is all under ice, and all the way up through the Salish Sea further north as well is covered under ice. And this ice age ended about 12,000 years ago, so it's fairly recent in the grand scheme of things. So most of our ecosystems are relatively new from that perspective. And depending where you were, you could have up to a mile of ice with a maximum coverage of about 18,000 years before present. So you can think about here in Bellingham, we'd have a mile of ice on top of Bellingham. So obviously a very different place than it is now. And that ended, again, about 12,000 years ago, which is not a long time ago. So because of that, most of our systems have just kind of rebooted since then. And if we zoom out and look at it from space, you can really see, particularly if we ignore the border, you can see the Fraser River Delta here as one continuous feature that was carved out by ice. All of these were carved by ice, all of the canyons carved by ice, and ice pushing out and flattening out the Fraser River Delta. So all of this is very recent. These are all new landscapes that were formed by glaciation that just ended 12,000 years before present. And if you kind of zoom out a little further from our local environment and think about really comparing the Salish Sea to other areas. And one thing that makes the Salish Sea so fascinating is there's all these little inlets, there's all this topographic variability where you can be on the water and just look at huge cliffs and huge mountains right next to sea level. And there's this really diverse kind of jagged shoreline that has all this habitat and all these little inlets. And if we compare it to, say, someplace further south, like, yeah, there's some variation here, but it's not as complex as we have here. And that's because of all this, because of our Ice Age history and all this glacial carving that's happened that's made our landscape so diverse. And we can kind of zoom in and look at some of these areas. Here's Quadra Island. This is the very northern end of the Salish Sea. And you can see all of these little inlets, all of this variability along the shoreline makes our area massively productive because we have all that land-sea interface, all that intertidal area. We have all those shallow marine ecosystems, eelgrass beds, kelp forests, which are some of the most productive ecosystems on the planet, meaning they fix so much carbon. They have the highest rates of fixing carbon globally. And that fixing carbon, you can think about, in a climate change perspective is important, but the fixation of carbon is the conversion of sunlight into food. And so these are very productive ecosystems. There's lots of primary productivity going on, which then is consumed by your secondary consumers, your herbivores. So it's a really, really diverse area and really, really productive area, largely due to our geological history. Just the physical setup of our landscape is one that would be really, really productive. So now that we have this setup, we have this like underlying, which for geology I guess is quite literal, this underlying complex environment. We have to think about what critters are here, what's the biology of the area. And I'm going to talk about two species, one herbivore and then one plant. Just as an example of a couple things that live in the Salish Sea. We'll go into depth on a few other species later, but there's just so many unique species that we can't go through them all, so we'll just talk about a few of them. And one of them are deer, and there's actually kind of two main species and then some subspecies. So the white-tailed deer is typically further to the east. The mule deer, which has two subspecies, the Columbian blacktail and the Sitka deer. So if you're on western Canvas and you see a deer walking around, that's a Columbian blacktail deer, which is a subspecies of the mule deer. And if you're in Sitka and you see a small deer, it's a Sitka deer. So mule deer are largely a west coast species, west of, and then along the coast we have the Columbian blacktail, which tend to be a smaller subspecies of the mule deer, and then further north is the Sitka blacktail deer. And Columbian blacktail thrive on the edge of the forest, and so we often see them on campus wandering around in the meadows, and they tend to be less afraid of people here than other areas, but nonetheless they typically bed in dense, darker areas adjacent to open areas that they can forage in, open grasslands. And so excuse me, it's a species that needs both of those things. It needs a dense forested area to take cover in, and it needs an open area for browse. And the Sitka deer It's a black-tailed that lives in southeast Alaska through central BC. They're really abundant in Haida, so much so that they have a daily limit of 5 deer per day, which is a pretty astonishing number of deer, but those tend to be a bit further north. And deer, in general, across the U.S. have undergone this pretty interesting population change. And the reason I'm bringing deer up is because it's similar to some other species as well, so it's kind of a good lens to think about. That estimates, like at contact, put deer just under 45 million, and then populations persisted for quite a while, and then there was a big drop-off into the early 1900s. And this actually, as a bit of an aside, relates to the Crow Treaty, I think is the Fort Laramie Treaty, and the recent Supreme Court case that in the treaty it said that, at least the Treaty of Fort Laramie, that the tribe, preserve the right to hunt on unoccupied lands. And it was mostly around elk. And at that time, the elk populations were just going down so dramatically that the federal government didn't feel like they were giving anything up with that. They were operating under the assumption that elk were going to go more or less extinct. And so by giving away that right, they weren't actually giving up anything. And so mostly driven by market hunting, that the majority of meat, of animal protein, was coming from hunting at that time, that really drove populations to near extinction levels, to very, very low numbers. And through conservation efforts, many of the deer have then rebounded. Blacktails, mule deer, blacktails, and others have not come back as well, although the coastal blacktail are doing quite well. Both blacktails and also whitetails can do pretty well at that urban interface. And so, again, using the example of deer on campus, you often see deer in these urban areas, that they tend to adapt pretty well to that. And it's interesting that you see this increasing in deer populations. We also have a decrease in deer harvest, primarily driven by the overall nationally, we're seeing a reduction of hunters. And so now we have the system where deer are back on the landscape. They're really in that kind of urban environment as well, that fringe habitat, but there's less harvest of them happening. And that starts to bring up questions around overpopulation and concerns about that. And if you spent time in the San Juans or in any kind of small islands to the Gulf, there are some islands that are just really densely populated with deer, and then we have to say, well, what are those animals doing on the landscape? What is this large population of herbivores doing, particularly in the absence of hunting? And this paper by Tara Martin et al. Is a really cool one, where she and the co-authors looked at a bunch of different islands in the San Juans and the Gulf Islands, and looked at the density of deer and how that related to the plant communities, and then the songbirds that are dependent on those plant communities. So looking at how many of these large herbivores are out there, how is that impacting the plants, and then what are the impact of those plants on other things, in this case particularly songbirds. And so they did this study in a couple of islands in the southern Gulf, which is the Canadian side of the line, and a couple islands here in the U.S. San Juans. And they picked a gradient of no deer, medium amounts of deer, and lots of deer. And what they found is that with increasing deer, there's massive impacts on the vegetation. So here, this first column are 3 different islands, one that has no deer, a moderate amount, and lots of deer. And they're similar habitats of just looking at the understory, and so we can see the no deer area is full of ferns, really dense. The moderate, a lot of the ferns are gone, but we still have some kind of grass and some vegetation. And in the areas with lots and lots of deer, there's almost nothing on the forest floor. Any little green thing that pops up gets browsed down pretty quickly. And then here's a similar story. We're looking at native shrubs. As you can see, the no deer area of a nice full shrub with lots of vegetation all around it. Moderate deer area, you can see there's been some trimming of the shrub down here, but there's still some kind of grasslands around. And in areas with high densities of deer, this is Sydney Island, those shrubs from basically deer height down are just completely eaten, and just the top of the shrub is surviving, and everything around it is browsed down pretty tightly. And so the purpose of their study was to look at deer density, plant communities, and then how that related to songbirds. So these are species rank curves. So this is saying in these 3 areas, low, moderate, and high, how many songbirds did we see, and what's the distribution of those? Did we find 100 species and we found 10 of each species, so it's very even? Or did we find 100 species and 1,000 of one type and the other 999 and we only found 1 or 2? So how even is that distribution? And so proportionate rank abundance is that number of, is there a whole bunch of these relative to the other? And in the low browse areas, in the low deer areas, we found a large number of the higher rank species. So we found a whole bunch of a certain type of bird, where in the high browse areas with lots of deer, we found those same birds but in lower abundances. So it turned out that having a lot of deer on the landscape didn't necessarily alter the type of birds you see, but it alters the density of birds that you see. And so that's important because while they didn't see a massive decline in the species that are out there, what they did see is a reduction in the population. So as there's natural waxes and wanes of populations through time, having a lot of deer on the landscape could really damage these songbirds. If there's a low in the population, they might not be able to withstand it, that there's less carrying capacity in the environment. So there's for sure a very visible impact on the plant communities, but then also an impact on the bird communities that are reliant on those plant communities. Next, I want to talk about camas. Camas is often called, if you relate everything to salmon, it's called the salmon of the land, meaning that we often think of Coast cultures and we think of salmon and we think of, oh, they just ate salmon every day, it was just salmon, salmon, salmon. Well, that's not true. There was a wide variety of food resources utilized. One of them, arguably one of the most important, is camas. And camas is a member of the lily family. And it forms this beautiful bulb here that's roasted and consumed. There's 2 main species of camas. Camas lectilinei, or the great camas. It's a much larger species. And Camas quamish, which is the common camas. They have similar distributions. The great camas tends to be more common on the mainland and larger island. In quamish, the common camas tends to be more common on smaller islands. It's a perennial herbaceous monocot. Particularly for the great camas, they can be up to 50 inches tall, which is huge. They have a multi-flowered stem with 6-petaled flowers, lilac pale to deep purple. And here's an image of some of the bulbs that Abe Lloyd dug up. These are relatively kind of like average-ish size bulbs. We'll see some pictures of some larger bulbs in a bit. This is work from Brenda Beckworth, who did her PhD at University of Victoria looking at the distribution of, this is 4 different camas species, but Quamash and Lectilinii are the 2 that we're primarily concerned with. And so Quamash are the circle dots, and Lectilinii are the kind of grayish triangles. And this is looking at, for Quamash, there's a number of subspecies as well if you want to start getting a little bit more into the weeds with it. And so up here we have mostly the maxima subspecies of Quamash, or the Camas. And this talks about the differences between the 2 species. Lectilinii, the giant camas, is a larger bulb than Quamash, the common camas. Bulb depth, again, tends to be deeper compared to Quamash, the common camas. The leaves tend to be a few larger on the giant camas, and they tend to be a bit taller. Oops. And then the timing tends to be a little bit different as well for seed set and dispersal. It tends to be a bit later with the giant camas. Part of that's driven by habitat, that the giant camas tends to be found in a little bit wetter areas with deeper soil compared to Quamash, which is often found on little islets, little rocks out in the San Juans that have a really thin amount of soil. And so these things need to get up, they grow up, they need to put out flowers and put out seeds really by June at the latest, because there's just not enough rain, not enough water to sustain them, where the giant camas can live in a little bit deeper areas. And to identify the differences, you really need to have the flowering stage, that the tepals on Quamash, the common camas, one curves downward, and on the giant camas they all kind of curve upward. And so the giant camas, when the flower dies, the petals come and cover the seed, where in Quamash they kind of fall away. So it takes a bit to tell the difference between the 2. Actually, on campus we have a fair amount of Lectilinii, the giant camas. And there's also concern of death camas. So you're often told, don't eat the white flowers. We have white camas on campus, so it's totally fine to eat. It happens to be a white variety, and we think that was due to some selective crossbreeding a faculty did like 30 years ago. So you can, thinking back to Mendel, you can crossbreed or selectively breed plants to get out different color morphs. So it's not only just a white flower for death camas, but it's this compound, kind of smaller flower as well, and the stalk's a bit different. But if you're out picking camas, then for sure be wary. And you can see here the flowers, petals are wrapped around here. So this is a giant camas. And so death camas grows about 70 centimeters tall. The bulbs look a lot like onions, which is kind of what camas looks like too. But the flowers are cream colored, and they grow in those clusters. And they tend to flower about the same time, April and May, and so that's why when you go out to harvest camas, it's important to go out during the flowering season so you can differentiate between death camas and real camas, because afterwards, after the flowering's done, the bulbs look more or less similar. And death camas is poisonous. It's poisonous to humans as well as livestock. You have to eat a fair amount, 2 to 6% of your body weight to be fatal. So if you think about, if you weigh 100 pounds, you'd have to eat between 2 and 6 pounds of camas. If you weigh 200 pounds, it'd be between 4 and 12 pounds, which is a lot. But I did talk to somebody who ate some death camas once on purpose to see what it was like. And there for sure in effects, he kind of made himself stay up overnight and drink water and kept moving. but his body was kind of cramping up and really trying to slow him down and kind of stop. And so he kind of pushed through that. But in general, you should avoid it. This is Brenda displaying the distribution of camas with the different kind of broad indigenous groups over that area, showing that it was used by lots of different people, and they all had a slightly different way of preparing it and dealing with it. Now here we can see some pictures of camas in Brenda's hands. And so before, Abe had like 4 or 5 in the palm of his hand. Here she's got 4 or 5 like cups between both of her hands, big, giant, fat camas. And so that comes about through cultivation. That those are big, fat, happy camas. And one of the ways that camas meadows were maintained is by burning. And so burning was an important feature of the landscape, that every between 4 and 7 years, small light fires, small, not very intense fires were lit that burned across the landscape, recycled nutrients, and kept the landscape open. That if you don't burn, then you get lots of trees kind of packed in really tight, and there's not a lot of sunlight hitting the forest floor. Where if we burn and kind of keep these areas more open, that's allowing more light to penetrate to the forest floor, and it's opening it up for lots of both plants for deer and other herbivores to graze on, but also traditional foods that people wanted to eat. And so here are some quotes from Hudson's Bay Company's Fort Victoria Journal, which is roughly where Victoria is now. And the timing, these are really interesting because it gives you the timing of it. So when people lit these small fires, and you can see they're over 3 different years, 1846, 1847, and 1848. And the quotes are more or less the same. The weather's now getting very hazy in consequence of the smoke from the fires that which the natives made in all directions. The fires now begin to spread over the country. Very dry weather and hazy owing to the fires that various directions through the woods and prairies. Here's another quote from 1849. It says, "The miles of the ground were burnt and smoky, and miles were still burning. The Indians burned the country in order to promote, more especially the roots they eat. The fire runs along at a great pace, and it's custom here, if you are caught, to gallop right through it, the grass being short and the flame is very little, and you're through it in a second." So that's a really cool quote saying that you can just imagine it's like fires like cruising across the landscape. And normally if you're caught in a fire, you would be concerned. But here they're saying, just get up at a gallop and you just kind of jump right over it. It's just a small, fast, not very intense fire, recycling nutrients and promoting food species. So it's one way that these ecosystems were managed that has been largely lost, and that's a big piece of shaping our landscape that's fundamentally different today. Camas was high in fiber. This is a quote from Father Nicholas Point. They did some fermentation of the camas as well, but despite their inventiveness, however, settlers quickly recognized the digestive side effects of camas overconsumption. Father Nicholas Point explained, "The digestion is accompanied by very disagreeable effects for those who do not like strong odors or the sound that accompanies them." David Douglas of the Douglas Treaty also commented on the flatulence caused by eating too much camas, saying that the strength of wind almost blew him out of a Chinook dwelling. So these are high fiber foods that if your stomach's not used to them can cause some side effects. Harvest was mostly May to July-ish. Again, it depends on the local area. That when they go to flower is kind of dependent on the length of a growing season and how much water is available. If you're in an area that you're going to dry out pretty quickly, you got to get up, get the flowers out, get the seeds out, and then kind of go back into a dormant stage. Yeah, it says here that the harvest when the flowers and stalks were visible is almost a universal practice, to watch out for the death camas as well. And camas areas were managed and inherited, and they were inherited on the maternal side. So it was a woman's area, it was in her inherent right of where she could harvest camas. And it's a bit different than ownership. We often use the word proprietorship. So it's not an area that they owned in like the sort of Western sense of like, it's my domain, I can do whatever I want with it. It's a stewardship responsibility to that landscape, that it was part of the family, that it wasn't, theirs to remove all the camas and put in a strip mall. It was an inherent responsibility to that land and then to the plant to make sure that they are properly maintained and persist in the future. And these camas beds were often marked by rocks as well. And so on Stewart Island, there were lines, which is one of the northwestern San Juan Islands. There were lines of cobbles in the shallow soil terraces that appears to have been dug. And so they talked about the establishment of these plots, and how people would clear out plots and then move the stones to the edge and build a little wall around it. That served the practical purpose of knowing what's the boundary between the camas and not camas. What area do we need to add seaweed and do other fertilization of? And so typically they'd go in and check an area. You can, depending on the area, the goal is to have a really nice fluffy black soil and then kind of a sod over that, so that you can just kind of pull back that sod and then the bulbs will be there, and you can pull the bulbs you want, flip the sod back over and let the young ones continue to grow. Ones that are too large are left alone. They're getting ready to split and become two camases, and the smaller ones were left there to grow longer. And many folks also, while they were there, took the seeds off the dead stalk and then sprinkled them around in the soil as well. So actually physically planted the seeds as well. So a lot of active management, a lot of tending to these areas. And once you get your eye calibrated, you can actually kind of walk up to a camas and figure out about how big it is based on the number of leaf, the flower height, and the stalk height. And so, and particularly these are areas you're going back to time and time again, that you sort of have a feel for where they're at in the harvest cycle as well. But in a new area, you can make some relationship between the above ground biomass and what it looks like, and what that below ground biomass would be with the actual camas bulb that we're interested in eating. And camas can reproduce in a number of ways. One is offsets of that bulb, so it's a bulb species, so they can kind of make a second offshoot that will then become its own plant, or by sexual reproduction and producing seeds as well. So you can see Brenda's hand here, a bulb, and then it'll offshoot from that. So you could harvest this bulb and actually put the offshoot back in. This is pretty amazing to me, that harvest rates. So when we talk about camas and people talk about camas as being important, well, what does that really mean? Well, a family could harvest 6 50-pound sacks in 2 days. And traditionally, a family would gather as much as 4,500 pounds of camas a year. That's a ton of camas. That's, well, over 2 tons to be exact. That's a fair amount of camas. A lot of that was consumed within the family. Some of that was also traded. It was a massive trade. Species are traded with inland groups in other areas to the north that don't grow camas as well. But that's a lot of camas to be harvesting in a relatively short period. We're talking about kind of May through June. So in about a month, harvesting that much is a lot. I mean, it's a full-time job for about a month of just digging camas, which would mean there has to be a ton of camas on the landscape as well. So like today that wouldn't be possible. Camas is just not that abundant. The bulbs aren't as large. They're not being maintained. And so it takes a fair amount of work to accomplish that, not to mention the post-processing, the cooking and the drying and preserving of the camas, which is also a fair amount of work. So after digging, it was common that seaweed would be applied. A lot of the camas, particularly again on the islands and the islets, is near the intertidal zone, and so going and collecting that beach rack and bringing it back, putting it on top of the camas, provides excellent nutrients, and so it's direct fertilizing the camas, burning the area to reduce the undesirable species, to recycle those nutrients. And then a lot of that camas was cooked right away, about 100 pounds at a time, until you reach your 4,500 pounds for the year. It was typically dug and cooked in pit cooks. And a pit cook is where we dig a big hole, line it with rocks, build a fire, let that fire burn for a number of hours, and then you just kind of sweep out all the ashes. Now you have all these hot rocks. And you lay down plants, you lay down the camas you want, cover that with kelp and green branches, and they basically steam. And they steam for 24 hours or more. That takes a long time to really break down the camas into an edible form, that when it's fresh out of the ground, it's not that edible. And that's because the main carbohydrate is inulin, and it's a really complex carbohydrate. And so we need to break that down to fructans, which are fructose and its friends. And that takes it from a carbohydrate that's largely indigestible to one that's easily digestible, and it's also quite sweet. And it's often, I think it's interesting to think about sweetness, right? Like our palate is so set for processed sugars that, you know, what we would have thought of being sweet 500-600 years ago, we might not think of as being that sweet right now. But for sure, camas was valued for its sweetness, and it does have a sweetness when you cook it, but it's that long, slow process of breaking down those complex carbohydrates into simple carbohydrates that are easy to digest. And then once they were cooked, they could be pressed into cakes and dried and stored, and then rehydrated later for consumption. Many were given away at potlatch or ceremony, and they're often traded with groups to the east and to the north as well. So you have to cook them right away, and then they can be pressed and dried and traded and stored for a long time. But there's a whole bunch of work that has to happen in a relatively short period of time. And camas is one window we can think about what does this interaction between like people and environment look like. And we could think about camas as the center of this. And so if you think about camas here in the population management, to maintain a single camas bed, you have to do things like weed, replant, till, dig, transplant, selective harvest. You have to do some certain things to manage that population, deciding, and the population being the patch of camas, like what do we need to do to maintain that little patch to make sure we're not eating too many, we're not over harvesting, and make sure that patch is going to persist. Then we can think about the more community management, the clearing of areas, the burning, fertilizing, opening up more space for camas and maintaining that. And then on a larger scale of all these camas patches around the landscape, how does that relate to people's seasonal pattern of movement? During the camas seasons, they need to be over by those camas harvest areas. There's site rotation, that not every site was harvested every year. There's ownership or proprietorship. There's exchange and redistribution. So social accountability and access and oral traditions all relate to that landscape of camas patches all around the Salish Sea. Who gets to go there? When do they get to go there? What are their permissions? What are the rules? What's the accountability of that? And you can build all of that into thinking about the resource use of the area. So you can use camas as one kind of through thread to think about how people interacted with and moved and interacted with each other and interacted with the Salish Sea for thousands of years. And that's like one really nice kind of through theme to think about one species and how all of these different aspects of society and ecology kind of are intertwined around it. And we also have the abiotic environment, so the weather and temperature and rain and all of that are really important. We tend to have a maritime west coast climate, which means our hottest month averages around 72 degrees, and our coldest month might average around 0. So relatively mild. Throughout the Salish Sea, rain is actually really variable. So we think of this area as really wet, but certain areas are not, particularly like parts of the San Juans and the Gulf Islands that are shadowed or in the rain shadow of Vancouver Island. So rain clouds come hit Vancouver Island, the west side, tons of rain, but then when most of that precipitation falls out before they come across Vancouver Island, and then your low-lying islands like Lopez gets about as much rain as Spokane, kind of Yakima area. It's a large island, but it's very low, and so most of that rain just floats right over. Other islands like Orcas or San Juan are higher, and so those rain clouds hit the mountains, and then will result in precipitation. So it's really, really hard to say like where our average rain is X or Y, because it really depends on where you're at. And because of that, it's a pretty interesting environment. We'll have two islands right next to each other that have totally different plant communities, largely driven by the amount of rain they receive. And we'll spend a lecture talking about human populations and changes. I talked about a couple examples of Coast Salish management, and then how that's changed with settlers and arrivants. Our current population is around 8 million. We're estimated to grow to 9 million by 2025, which sounds, I guess, far off. I don't know, my daughter's going to graduate, my youngest daughter, in 2031. She just had her kindergarten graduation, so 2031 is when she graduates. So in that time frame, it's not that far off, and our populations have been growing very rapidly and will probably continue to grow very rapidly. Primarily driven by the movement of people leaving the Rust Belt and leaving more industrial areas, coming to more tech-centered areas, Seattle area, Vancouver, very fast-growing populations. And so the likelihood of us continuing to be one of the fastest-growing parts of U.S. and Canada is likely to continue into the future, and is evident by one metric of our rising house prices, cost of housing. So we're likely to experience a ton of population growth.